Let's understand potential energy of a string. The spring force is conservative variable force. Let us consider a block attached to the spring and resting on a smooth horizontal plane. The other end of the spring is attached to the rigid wall. For an ideal spring, the spring force Fs is proportional to displacement of the block from the equilibrium position. The displacement may occur either in positive direction or in negative direction. The block is initially at x equals to 0, that is equilibrium position. Then Fs is proportional to x. Removing the proportionality constant, we get Fs equals to minus kx. The negative sign shows that both spring force and displacement are in opposite direction, where k equals to spring force. Let us consider two situations for displacement of a block. When spring is stretched, that is, block is pulled outward, then the displacement occurs in positive direction. In this case, the spring force is toward left and displacement toward right, that is, Fs is negative and x is positive. When spring is compressed, that is, block is pushed backward, the direction of displacement is in negative direction. In this case, spring force is toward right and displacement toward left, that is, Fs is positive and x is negative. Now, let us consider a block is stretched outward with maximum displacement xm, then work done by spring force delta W equals to minus Fs dx, that is, dW equals to minus kx dx. Integrating both sides for total work done from displacement x equals to 0 to x equals to xm, we have integration dW equals to minus integration of 0 to xm kx dx. This implies Ws equals to minus half kx square by 2 from 0 to xm. Substituting the values in this equation, we get Ws equals to minus half kxm square. Now, graphical representation of spring force. Now, see the graph of Fs and x. From figure, the work done by the force F is equal to area of triangle OAB. Also, angle ABO equals to 90 degree. We have area of triangle OAB equals to half of base into perpendicular. On substituting values of base and perpendicular in equation, we get area of triangle OAB equals to half xm into F. Here, the pulling force F is taken as positive because external force overcomes the spring force. Hence, area of triangle OAB equals to half kxm square. Since we calculate the work done by spring force when it is compressed, that is, Wc equals to minus half of kxe square. And work done by external force to compress the spring is Wc equals to plus half of kxe square. When the block is moved from initial displacement xi to final displacement xf, the work done by spring force is given by Ws equals to minus integration xi to xf kx dx. On integrating it, we get Ws equals to minus half k xf square minus half k xi square.